coming up, we're going to end up talking the different types of curves. We've already seen some rose curves in this section. They're curves that basically have petals on them, so they look like roses, and they are of the form, if you look up here, they have a cosine or a sine, where like that's really all there is to it. There could be a number in front and there can be a number in front of theta, but otherwise it's just cosine or sine. And a and n are both numbers. N in particular has to be an integer, it says, but they're both numbers. And what happens is that we can list out all of our analyzing things from this graph. So the domain for polar graphs is, it kind of may feel backwards than from the way that we do it with rectangular coordinates, because the domain is what theta is. That's a terrible theta. That looks really awful. Let me try again. Our domain is, that's still awful. I give up. Okay, our domain is what we can plug into our function and get an answer. Well, we're allowed to plug anything in for theta for this graph, so that's why it's all real numbers for our domain. Our range is talking about what R values we will get from our function, and so we'll figure out that because it's cosine and sine, and because of the way cosine and sine work, we're only going to get values between negative a and positive a. So it's kind of backwards because we have these points r theta. Okay, so you might think that, oh, r is the domain and theta is the range, but it's not. It's backwards, because think about the way it's set up here. Like, this is more like our y, and this is more like our x, because it's y equals something, right? Okay, so these are continuous functions. You can draw them without picking up your pencil. If you had to, you could. You may
could just draw those suckers out the whole time.
Yeah, when you're drawing them, you may be like, okay, I want to make this petal perfect, and now I'm going to make this petal perfect. And so you may end up picking up your pencil, but you could, if you really had to, you could draw it without picking up your pencil.
Yeah, and if you watch your TI calculator, it'll graph it out perfect for you.
Yeah, it
exactly
will.
How it should go.
Yeah. Symmetry is based on what n is. If n is even, then we have symmetry, a lot of symmetry.
Yeah, a whole bunch.
X, Y, both of those axes and the origin.
Did you say axes?
I don't know what the plural of axis is.
I don't either.
So I just make it up.
Okay.
If n is odd, and we're talking about sine, it's symmetric about the x-axis. Hey, will you look at a pre-calc book?
Pre-calc book.
Okay. And if n is odd, r, it has symmetry about the y-axis. I want to make sure that that's right, because I feel like that's backwards.
I got a pre-calc book right here.
Okay.
And we'll just check it out real quick while you're...
With these graphs, when we say bounded, what we're saying is that instead of thinking about it not going to infinity or negative infinity, because r is now talking about a radius, we're saying that we're not allowed to go to infinity for r. Okay, so r is different. Yeah, I was right. It's backwards.
Okay, all right. It's backwards. We got backwards whoopsies.
So this is y-axis. Because sine and y go together. That's what tripped me up.
Yeah.
And cosine goes with x.
I'll take full blame for this one, because
Okay.
I fouled it up when I created it last year. Yeah,
Okay.
so sorry,
yeah.
my fault on the slide. Okay.
Yeah, so bounded, though, we're talking about, it's more of a circle bounded. Is there a circle we could draw where all of our graph is inside that circle? And if there is, then it's bounded, because our R values do not go to
doesn't
infinity.
go past that, yeah. It's not a straight line or some crazy business.
Yeah. Our max R value, we've already looked at that it's whatever A is.
Yeah.
There's no asymptotes.
That would be your amplitude.
It is your amplitude,
right.
Yeah. Your number of petals for this is n if n is odd. So if it's 3 theta, we have 3 petals. It's 2n if n is even.
Hey, that 2n looks...
That looks a little drawn in.
That's a little funny there.
Yeah. Oh well, we'll just move faster.
Okay. All right.
2n. So if it's 4 theta or something like that, well, there'd be 8 petals. Speaking of which, let's analyze this rose curve.
Let's do it.
So some things that we know from this are the 3 in front is going to tell us the length of the petals.
Right. So each petal length has a 3.
Has 3, yeah. And the 4 in front of the theta tells us that we'll have 8 petals.
8 petals, yep. And there's some other clues in here too, like...
It's sine, so...
Sine means...
but it's even. So it's symmetry about the x, y axis and the origin.
Right.
And so there's a couple different things this could look like. And if we had to graph this without using a calculator to graph it, we would basically want to plug in, I think, like 0.
Yeah, we want to know where we start.
Okay. So if I plug in 0.
4 times 0
is 0.
Yeah.
Sine of 0 is 0. That's not particularly helpful.
No, but 3 times 0 is 0, so we're starting at the origin.
Yeah, so we have a point at the origin, but we want to kind of figure out where one of our petals is actually going to be. So we need to think about how could we make the sign end up being 1? What angle would we have to put in here?
The sign is going to be 1 where theta is pi over 2.
Right.
In general. So why don't we set 4 pi or 4 theta, let's set 4 theta equal to pi over 2.
4 theta equal to pi over 2.
Yeah, that'll tell us what theta needs to be in order to get a sine of 1.
Okay, so you divide both sides by 4.
Right.
So theta is pi over 8.
So pi over 8, we're going to be 1 unit
circle,
away.
But it's about right here.
But we can make a good educated guess.
Right.
Yeah.
We're saying at pi over 8, if you plug that in.
Check it out. Just check it out real quick. 4 times pi over 8.
Well, that's pi over 2.
Yeah. Which
and
is
sine
1.
of pi over 2 is 1, so this is 3.
Yeah.
So that tells us that's
Bingo,
where
bango, bongo.
one of our petals is.
Oh, there's symmetry all over the place with this one.
Right, and there's 8 petals. This one's kind of tricky. Like, there's just petals, like, all over the place. All of length 3. Like, trust me, this is exactly what it looks like on your calculator.
Exactly.
Okay, now we'll have to analyze all the things. So domain.
All reals.
That's right. We can plug in any theta we want to
Any
get an answer.
theta. Yep. The range is going to go from what do you think? From -3 to 3?
Yep.
That's what I say.
And those are those inclusive?
Those would be included because that's the tip of your petals.
Yeah. Totally.
Totes inclusives.
It is continuous.
Yes, it is. As
Even though
all
I
rose
picked
curves
up,
are.
I picked up my pencil, but that was well, actually, I don't know if I did pick up my pencil that time.
You might not have.
We said that the symmetry.
X, Y, and origin.
And you'll see them do X with the dash, Y dash. We/they are being lazy and not writing axis twice. No big deal.
No big. In GBD.
Bounded. Totally bounded.
Totally bounded because it doesn't have some line running off into the hinterlands.
Yeah, this max R value is in place of us saying we have maximums or minimums, and it's really kind of saying the same thing.
Right.
Right. We just have a different idea of maxes and mins for polar coordinates. That's slightly different idea. No asymptotes.
No asymptotes at all.
Have you seen a polar graph that has asymptotes?
Yes.
Okay, cool. We'll talk about it later, maybe.
Yeah, I think it'll come up later.
Okay.
Maybe not an asymptote, but a directrix. Maybe that's what I'm thinking of.
It's even, and we already said it was.
It's going to be 8 petals.
Yeah. Well, that's not what I meant. N equals 4, so there are 8
petals. 8 petals.
Not N equals 8.
No, just 8 total.
There we go. Example 4.
All right.